Welcome everybody to another one of James's videos. Today we are doing type 5 of the trigonometric grade 11 equations and dealing mostly with difficult examples dealing with factorizing and identities. Okay, so for this one, just looking at it, I can kind of see a trinomial vibe happening, but the problem is that if I had to consider this to be a trinomial, the middle is sine times cos. So at the end of the day, I've only got a sine squared. So I am missing a cos squared somewhere. Okay. So there's no way for me, even if I change this into 1 minus cos squared, I've still got that sine theta in the middle. So like I said to you guys with regards to these questions, you need to think 5 steps ahead and you need to kind of foresee, oh, okay, this is looking like a trinomial, so let's try and make it look like a trinomial so I can factorize. The only method for this one, which is difficult, and it'll only come with more practice, and the more you expose yourself to examples, the better you're going to understand them. But the only way that we're going to be able to do this one is if we change and we bring in a cos squared somewhere. So how can we do that? The only way that we can bring a cos squared into this is by taking the 4 and timesing it by 1. Do you agree with me that I haven't actually changed this equation, because anything times 1 is just that thing, right? So the equation hasn't been changed. I've just written it in a different way, but it still remains the same. Now, what identity do we know in trigonometry that a 1 can change into? Well, isn't sine squared plus cos squared theta equal to 1? So surely I can change this 1 into this identity, and that's what's going to bring in that cos squared that I've been looking for. So let's see if it works out. Sine squared theta, 5 sine squared theta plus 3 sine theta cos theta minus 4 times sine squared theta plus cos squared theta equals 0. Okay, so now we need to times that minus 4 in. So 5 sine squared theta plus 3 sine theta cos theta minus 4 sine squared theta minus 4 cos squared theta equals 0. Okay, fantastic. Now that we've gotten to that point, do we see that we have like terms here? Yes, we do. That is a like term, and that is a like term. So what is 5 minus 4? That is 1. So that becomes 1 sine squared theta plus 3 sine theta cos theta minus 4 cos squared theta. That is in a trinomial that I can now factorize, because I have the sine squared at the beginning, the cos squared at the end, and then the combination of the two of them in the middle. Now, like I said in the previous video, if you struggle to see the trinomial with the trig functions, you can always let sine of theta equal, let's say, for example, x, and then let's let cos of theta equal y. And let's change it into algebra. So let's say, cool, it's going to be x squared plus 3xy minus 4y squared. That's a lot easier to factorize because we are familiar, obviously, with algebra, right? So let's factorize it. Equals 0. So it's going to be x and x. Factors of 4, that's going to give me 3. So we've got 1 and 1. We've got 4 and 1, we've got 2 and 2. So the factors that are going to work here is the 4 and the 1 and the 1 and the 1. So that's going to give me the 4, that's going to give me the 1, and I need a positive 3. So positive 4 minus 1. So we are going to say plus 4y and minus y. Okay, and that's how I factorized that one. Now, we can also, at this moment in time, we can also sub them back in. So let's make it, okay, so it's going to be x minus y equals 0, or x plus 4y equals 0. So what are we going to do from here? Let's sub our trig functions back into play. So we're going to have sine of x minus cos of x, or cos theta. Why am I saying x's, guys? Thetas minus cos of theta equals 0, or sine of theta plus 4 cos of theta equals 0. And now I can simplify them separately. So what is that rule that we use when we have sine and cos on both sides of the equals and the angles are the same? It's the tan method, isn't it? So in the previous video, I think it's type 2 or type 1, we dealt with the scenario where we have sine and cos on both sides and the angles are the same, which allows us to create a tan. So we can divide both sides by the cos theta. That turns into a 1. This is going to turn into a tan of theta equaling 1. This one, same concept. Let's divide both sides by cos. Those will end up cancelling. We have now created the tan of theta equaling -4. Okay, if the question is coming up in your mind, can tan of theta equal -4? Yes, it can, because if we think about tan graph, guys, tan graphs continue up to infinity and continues down to negative infinity. The range is not restricted like the sine and the cos graph. Okay, so what we would do from here is we do reference angle, and this one would be 45 degrees, and then we would say shift tan of 4. Remember, when we do reference angle, everybody, we do not take the signs into consideration, okay? So those are my reference angles for these two equations. We can also work out what quadrants we're going to be doing our general solutions in. Okay, so that we then take the sign into consideration. So where is tan positive? First and third, but because it's tan, we only have to do the first quadrant because it repeats itself every 180. Here we're looking for where tan is negative because it's a -4. That is in the second and the fourth, but again, we only have to do it in the second due to the fact that tan repeats itself only every 180. So we're going to say first quadrant here, and it's the theta quadrant. So we are going to say theta is equal to 45 degrees plus k 180. Notice the change of the k because tan repeats itself every 180. That is the general solution for that. And here we're going to do second quadrant, and that is going to be the 180 minus theta quadrant. So therefore, theta is going to equal 180 minus the 75,96 plus k 180. K is an element of integers. Therefore, theta is going to equal 180 minus answer. So it's 104,04 degrees plus k 180, and k is an element of integers. Okay, and this question was nice and short because they didn't ask us to solve for specific values. Do you notice in the question they didn't give us a domain? They just asked solve for theta, which means we only have to stop at our general solution step. Okay, just a reminder, guys, to look out for those identities in that factorizing technique. Like I said, the more you do, the more you're going to foresee it, the faster you're going to be able to do these questions because you're going to be able to see it and change the identities into their necessary forms so that it gives you a simplified answer. Now, also what I mentioned in the previous video, this section here, you don't have to do. If you can see the trinomial with the trigonometric functions, by all means factorize it straight. But if you struggle to see the factorizing, change it into algebra and then change it back into your trig functions once you've fully factorized it. Okay, guys, well, I hope you enjoyed that video. If you really did, please click the subscribe button at the bottom. And then also all these notes are available in the James book. So if you are keen for a copy, please comment, send us a message in the comments, or go onto the website and get in contact with us. And yeah, good luck for trigonometry equations and have a good one.